Welcome to a deeper dive into one of the most practical tools in algebraic toolkit, solving systems of equations. While individual equations allow us to model one relationship at a time, systems let us look at how multiple rules interact simultaneously. So mastering this more than just, it's just more than just a test taking trick, right? Success in Algebra 1 is a significant milestone that predicts future academic and career achievement. Today, we are going to learn how to solve a system of leveraging its structure using the substitution method. So the mindset should be, right, is that imagine you're a detective investigating a mystery with two clues. Clue one, two numbers, x and y add up to 25. Clue two, the first number x is exactly four times as large as the second y. So in algebra, we write these clues as a system of equations. X plus y equals 25 and x equals 4y, right? Our goal is to find the pair of values, x, y, that makes both statements true at the exact same time. So before you start doing it, think about what tool are you going to use, right? On the digital SAT, you learn multiple ways to solve these, right? Graphing, elimination, and substitution, right? So a rookie might use the same recipe for every problem, but an expert like you looks at the structure of the equation first, right? So look closely at our second equation, x equals 4y. It already has x isolated on one side. This is a massive math cue, right? That the substitution method is your most efficient path here. In algebra, substitution is like using a disguise. So equation 2 tells us that whenever we see the symbol x, we can replace it with 4y because they are equivalent, right? They have the same value. All right, now let's try to solve it step by step, right? Step one, we take our first clue, x plus y equals 25, and replace the x with its disguised value 4y. So the equation transforms from x plus y equals 25 into 4y plus y equals 25. Now, step two, we're back to the basic arithmetic, right? If you have four of something and you add one more of that thing, you have five of that thing, right? So 4y plus 1y becomes 5y. So our equation is now 5y equals 25. Okay. Now, we have to maintain equivalence, right? I've said that several times. To find the value of y, we need to undo the multiplication. Since the scale is perfectly balanced, we must perform the same operation on both sides to preserve that equality. We divide both sides by 5, right? So 5y divided by 5 equals y. 25 divided by 5 equals 5. So the conclusion we reach is that, y equals 5. Now think about the visual link, okay? The Cartesian connection. The truly understanding it, what we just did, we have to look at the personality of algebra as a tool of modeling functional relationships. If we were to graph both of these equations, right, on a coordinate plane, they would appear as two straight lines. By solving this, you aren't just finding a number. You're finding a point of intersection, the exact spot where those two lines cross, right? If you plugged y equals 5 back into our second clue, x equals 4y, you would find that x equals 20. This means the two lines meet at the point 20 and 5. So this Cartesian connection between symbolic steps and visual graphs is a superpower that will help you verify your answers on the test. All right, let's wrap this up. When you see a system of equation, don't just start pushing symbols around. Investigate the structure. Is one variable already solved for? If so, substitution is the way to do it, right? Use the disguise or sort the variables for its equivalent expression and preserve the balance. Always do the same thing on both sides of the equal signs. By moving flexibly between these strategies, you turn a complex looking problem into a simple one variable equation. In our next session, we'll look at the elimination method, okay, which is the perfect tool for when the variables are hiding in different kind of a structure. See you then.